Hi, I'm Professor Kelly, and this is a lecture on logic paradigms and an introduction to Prolog for CSCI 308 Programming Language Design. Let's start by talking about the zebra puzzle. The zebra puzzle is a famous logic puzzle, first appearing in Life International in 1962. The puzzle is in fact so famous and so popular, it's often called Einstein's puzzle because it was misattributed to Albert Einstein. The puzzle goes like this. It lists a series of facts, such as there are 5 houses, the Englishman lives in the red house, the Spaniard owns the dog, coffee is drunk in the greenhouse, the Ukrainian drinks tea, the greenhouse is immediately to the right of the ivory house, the old gold smoker owns snails. This is the 1960s, so everyone smokes. Cools are smoked in the yellow house, milk is drunk in the middle house, the Norwegian lives in the first house, the man who smokes Chesterfields lives in the house next to the man with the fox. Cools are smoked in the house next to the house where the horse is kept. The Lucky Strike smoker drinks orange juice, the Japanese smokes parliaments, the Norwegian lives next to the blue house. Then after this avalanche of facts, you're then asked, who drinks water and who owns the zebra? And then you stare at this set of facts thinking, what zebra? Nobody drinks water. This is a tricky little puzzle. But what if we had a programming language where all you had to do was type in this set of facts into the program, and then it would figure out who drinks water and who owns the zebra? That language is Prolog. So the learning goals here are, well, first of all, you should install Prolog. Check out the other video for that. You should explain what the logic paradigm is and what declarative programming is. Be able to distinguish between relations and functions, identify the 4 kinds of query in Prolog, and create Prolog programs using atoms, facts, rules, and lists. Programming languages can be thought as having a family tree. Most of the languages you know, probably all of them in fact, belong to the imperative part of the tree. So far, we have focused mainly in the past few weeks on object-oriented languages like C++ and Java. Now we're switching focus to the declarative part of the tree. Specifically, we're going to focus on Prolog, which is a logical language, which is part of the declarative family. Prolog is about as related to C++ and Java as humans are to octopi. So this language is going to be quite different from what you're experienced with. Logic programming is part of the declarative paradigm. Imperative languages describe a sequence of step-by-step instructions for the computer to execute. Imperative languages can be thought of as a lot like following a baking recipe or following the assembly instructions for a piece of furniture or for Lego. Imperative languages include C, C++, Java, Python, Bash, Perl, JavaScript, Fortran, and most of the languages you can think of. Conversely, in a declarative language, instead of giving the computer a set of instructions, you describe a situation and describe what must be solved in that situation, but you don't describe how. Declarative languages are based on symbolic logic or mathematics. Declarative languages include Prolog, OCaml, Lisp, and Haskell, and others. The logical paradigm implements symbolic logic. In particular, Prolog implements predicate logic. The code in Prolog or other logic paradigm languages is simply a set of statements describing what's true. Logic paradigm languages are good for good old-fashioned artificial intelligence, that is to say, artificial intelligence focused on automated reasoning and rationality, as opposed to many modern artificial intelligence approaches such that are based on neural networks. Don't try to implement a neural network in Prolog. Prolog is not for that, it won't work very well. Prolog is good for computational linguistics, constraint solving, and finding logical relationships. Prolog was developed in 1972 in France. Prolog is actually short for Programmation Logique, or logic programming in French. The particular version of Prolog we use is SWI Prolog, which can be downloaded from www.swi-prolog.org. The installation is described in a separate video. Prolog is different from other languages you've seen in that it uses relations instead of functions. Formally, a function is a mapping between two sets such that f of s equals t, where s is in one set and t is in the other set. An example of a function is log 10, which gives you 1. Functions map 1 to 1. You give it 1s and it gives you 1t. You give log 10, it gives you 1. A relation, on the other hand, describes a relationship between two sets where you have a set of pairs in the combined product of these two sets. A relation maps 1 to many. You give it 1s and it gives you all possible t's that are allowed for that s. For example, let's say we asked what orbits the sun, or orbits sun x. This is a relation involving the sun. Possibilities include Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Let's just stick to planets, or we'll be here all day. The basics of Prolog contain 3 elements. The first is atoms. These are literals, constants. They're represented either by lowercase words, such as moon or sun, strings, that is, things in quotes, such as hello world, and numbers, including both integers and floating point numbers, 0, 1, 2, 3.74. Prolog also has facts. Facts are statements about the world. They are unconditionally true. You just assert them in your Prolog program. For example, the sun is a star, or the moon orbits the Earth. Prolog also has rules. Rules are formally known in logic as horn clauses. An example of a rule is planet B, dash, that's the Prolog syntax, orbits B, sun. This is read as B is a planet if B orbits the sun. Or alternatively, it can be read as showing that B orbits the sun is sufficient to show that B is a planet. Rules can be more complicated. We can use a comma to indicate and. So we can have X as a satellite if X orbits P and P is a planet. So now that we know how to describe relationships and facts in Prolog, how do we ask Prolog questions about these facts and relationships? In Prolog, there are 4 different types of queries. Broadly, is this true, and how can this be true? So the first type of query is you make a statement, you assert a fact to the Prolog interpreter, and Prolog then tells you if it's true or false. For example, is Sirius a star? True. Is the moon a star? False. Does the moon orbit the Earth? True. Does the Earth orbit the moon? False. Note that the order of the atoms in the relation matters. We can also have unknowns in our queries. If you provide an unknown, Prolog tries to fill the unknown essentially with a value that makes it true. So if we ask, what orbits the moon? We get Earth. If we ask, what orbits the Earth? We get the moon. We can also have more than one unknown. We can ask, what orbits what? We can press space in the Prolog interpreter to get multiple answers. So the first answer we get is Mercury orbits the Sun. If we press space, we can get a second answer. Venus orbits the Sun. Press space again. Earth orbits the Sun. Let's say we don't want any more answers anymore. We press space one more time, we get Mars orbits the Sun, and then we hit return, and Prolog doesn't give us any more answers at this point. After we've hit return, we've told Prolog, no more answers please, we're happy. Prolog has linked lists, which are recursively defined. To declare a list, use the square brackets and use commas to separate the elements in the list. Square brackets with nothing in it is the empty list. As far as Prolog, there's only actually 3 types of list. The empty list, a list with something in it, and a list with a head and a tail, where the head is something and the tail is another list, specifically the rest of the list. Lists don't really come with many useful functions in Prolog. You kind of have to write your own. Here's a couple of useful helper functions you may want to implement for your own code. Let's say we want to get the length of a list. We can start by asserting a fact. This fact is the length of the empty list is 0. Now we can use a rule. This is a little bit more complicated. We can say the rule is, if we have a list, well, we can take the tail of the list. The underscore indicates we don't actually care about what's in the head. And the length. And so tail length if tail length, and length is tail length plus 1. In other words, the length of the list is going to be the length of the tail plus 1. This is a recursive definition. Prolog heavily relies on recursion in order to solve problems. We can also define index as a way of indexing into lists. Personally, I prefer indexing where we assume indexing starts at 1. You can write a version of this helper function where it starts at 0 instead, if that's what you're most comfortable with. Here we're saying that if we have a list and the index is 1, return the head. And by return, I mean there is no actual return. Instead, it's simply the third atom in the relationship, index. We can also define a rule where we state, okay, if we haven't actually found the head and index 1, then what we need to do is if index is greater than 1, there's a typo there, tail index is index minus 1, index tail index value. So what we're saying here is, all right, if we haven't reached index 1 yet, we need to subtract the index by 1 and then recursively call index on the rest of the tail in order to try to find the value. Here's an example of these functions at work. Let's say we have the list 1, 2, 3, 4, and we ask, well, what's the length? We can get 4. And we can also ask for the index. What is at index 3? Well, the answer is 3. And there are no other possible answers, so if we press space, we get false. So let's go back to the zebra puzzle. We can implement the zebra puzzle in Prolog. We can take the 15 facts and just simply translate them into statements of fact in Prolog. Half this Prolog program that I've found on GitHub, see the link below, is actually not dedicated to describing the 15 facts. The other half is just dedicated to describing what it means for a row of houses. Like, what does middle mean? What does it mean to be the first house in a row? What does it mean to be right of? This set of spatial relationships is actually kind of complicated. Though it's very intuitive to humans, it has to be spelt out explicitly for Prolog. But with this Prolog program in place, we can now ask, who drinks water and who owns the zebra? To do this, we just say puzzle houses, and it solves who's in all the houses. From this, we can actually see that the person from Norway drinks water, and the homeowner from Japan has the zebra. To sum up, check out the other video to install Prolog. The declarative paradigm, it differs from the imperative paradigm in that it's concerned with what rather than how. That is, you describe a situation and the programming language solves it for you rather than you having to spell out step-by-step instructions on how to do that. The logical paradigm is specifically based on symbolic logic. The idea is your program should look as much as possible like simply a set of statements in symbolic logic. And then when you execute the program, it does the messy business of solving the symbolic logic problems for you. The distinction between functions and relations is that functions are one-to-one, whereas relations are one-to-many. Prolog has 4 basic questions. One is you give it a fact and it tells you if it's true or false. The other is you give it at one unknown and it figures out what that unknown could be. And that could either be the first in the relationship or the second. This is actually general. Queries can have any number of atoms in the relationship, and they can also have any number of unknowns. Atoms consist of things like Mars, 0, 3.5, and Hello World. Relations consist of things like orbits, Moon, Earth. Rules are like planet B if B orbits the Sun. And lists are created recursively in Prolog. You can state a list using commas to separate the items, and then square brackets to indicate the beginning and the end of the list. But basically, as far as Prolog is concerned, there's only 3 types of lists: the empty list, a list with something in it, or a list with a head and a tail, where the tail is the rest of the list. And that is Prolog.